Wow, the amount of data swirling around these days is just, it's incredible. Trying to manage it, let alone actually use it, that feels like a huge job.
Oh, absolutely.
Yeah.
It's like we're drowning in information, isn't it?
Yeah.
And it's not just the volume. It's, how fast it's coming at us and all the different shapes it takes. A lot of the older systems, well, they just weren't built for this, so people feel stuck.
Yeah, exactly. Which is why we wanted to do this deep dive on Snowflake today. It's a name you hear constantly in modern data conversations. We've pulled together some interesting articles from the Snowflake Builders blog to guide us. And the idea is to get past the marketing buzz, really understand what makes it tick. Things like why open standards matter to them, how they work with other tools, and also how they handle, well, everything from neat tables to messy PDFs, even real-time data streams, and of course, AI and ML. So think of this as like your shortcut to getting the real story on Snowflake's value.
Precisely. We're not here to just read off a feature list. We want to pull out the key ideas from these sources and connect the dots for you, show you the bigger picture.
Okay, so let's start with what makes Snowflake different. You always hear about speed, right? The speeds and feeds, like Paul Needleman mentioned in one of his articles.
That's right, the one on security and governance. It's a very common focus. People love comparing benchmarks. Who's faster? And look, speed is important, no doubt, but Needleman makes a really good point. It's only one part of the story, a much smaller part than you might think sometimes. If you're making a big decision about your data platform, you need a much more holistic view.
Holistic use. So what else is critical then? What are those other pieces?
Well, think about it. How secure is your data, really? Can you trust it? What about governance, compliance, all that crucial stuff? And how well does it actually play with the tools you already use, your workflows? Does it really solve your specific business problems? And maybe the most basic thing, is your data going to be there when you need it? Always. Often those questions are way more important than just raw speed.
Right, yeah. Fast analysis doesn't mean much if the data isn't safe or if the system's down when you need it. Okay, so it sounds like security and governance are really like foundational for Snowflake.
Absolutely. That security article by Needleman really hammers this home. Security isn't just bolted on, it's woven into the platform's core. Like data encryption. It's on by default. Always. For data sitting there and data moving around.
By default, okay.
And if you need even more control, maybe for compliance reasons, you can bring your own encryption keys, customer-managed keys.
That gives you more control.
It does, which is pretty vital today with all the cyber threats and regulations.
That default protection is a great start. What else do they do on the security front?
They give you a lot of control over who gets in, network policies, login policies. You can say only allow access from these specific IP addresses, or maybe only from inside your company's virtual private cloud, your VPC. It means only trusted networks can even talk to Snowflake.
Yeah.
And you can get granular with user roles and even how they connect. Maybe analysts can use the web UI, but automated scripts using ODBC are restricted, for example.
Wow, that's really specific control. And I think I read something about private networking too.
Yep, things like Private Link let you set up a direct private tunnel between your network and Snowflake, so your data never even touches the public internet. Better security, maybe even better performance.
Okay.
And for proving who users are, they push hard for single sign-on, SSO, using things like Azure AD or Okta. But if you're not using SSO, then it's strong passwords, multi-factor authentication, the works.
So layers of security, data protection, access control, identity verification. Makes sense. Now, what about governance? That always feels like a big, complicated beast.
It can be, for sure. But Snowflake tries to make it manageable with sort of a layered approach. You've got the broad strokes, role-based access control, RBAC. You give permissions based on job roles, analyst, engineer, whatever. That scales well.
Right. Standard practice.
But then they add really fine-grained stuff on top. Column-level security, row-level security.
Yeah.
So you can mask out, say, credit card numbers in a column, even if someone can see the rest of the table.
Okay. Masking.
Or you can filter rows. Maybe the West Coast sales team only sees West Coast data, that kind of thing.
Yeah.
Super important for privacy rules and just general data hygiene.
That level of detail, controlling who sees exactly what piece of data, that seems incredibly useful, especially with sensitive information.
It is. And they also have tagging and classification features. You can label sensitive data, maybe in a column called ColX, that doesn't sound sensitive, and then automatically apply security policies based on that tag.
Oh, clever.
Plus, they log everything. Who logged in, what queries they ran, what data they touched. It gives you a complete audit trail for compliance, and helps you spot anything unusual.
So you always know who did what when. Sounds great for security and for auditors. Okay, let's shift gears a little. What if things go wrong? An outage, a mistake? How do they keep data safe and available?
Right, availability and resilience. They've got several layers here too. First, for recovering from mistakes, there's this really neat feature called time travel. It automatically keeps old versions of your data whenever it changes. You decide how long to keep them. So you can query data as it looked yesterday or last week, or, and this is the big one, you can undrop a table you accidentally deleted.
Undrop, huh? I bet that saved a few careers.
I wouldn't be surprised. It's a fantastic safety net. Even if you don't have time travel set up for long periods, there's usually a short window to recover deleted stuff.
Okay, good to know.
Then there's redundancy for the data itself. Being cloud native helps. You get the cloud storage durability. But Snowflake goes further. They automatically replicate your data 3 times across different physical locations, different availability zones within a region.
3 times, automatically.
Yep, no extra charge, no setup needed. If one zone has a problem, your data is still safe and accessible in the others.
Okay, multiple copies in different places.
Right.
Smart. What about the computers doing the work? The compute?
Same idea there. Redundancy in the compute layer, too. Their compute clusters, the virtual warehouses, they're designed to run across those multiple availability zones. So if one zone hiccups, your queries can keep running elsewhere. And if a specific query hits a temporary glitch, Snowflake often just automatically retries it behind the scenes, makes everything more reliable.
And what if something really big happens, like a whole cloud region goes down?
That's where replication and failover come in. You can replicate your data to a completely different region, or even a different cloud provider altogether. You can set how often that replication happens based on how much data you can afford to lose, your RPO.
Okay.
And the failover itself is designed to be smooth. It's not just the data. They migrate user accounts, roles, permissions, settings, everything. Plus, they have this thing called client redirection. If you do failover, your application should automatically connect to the new active region without you needing to change connection strings.
Wow, that sounds incredibly thorough. A lot of peace of mind built in there. Okay, so solid foundation. Security, governance, resilience. Check. Now let's dig into this idea of open standards. Interoperability. Needleman's article mentions Snowflake supporting Iceberg tables, especially for connecting with Databricks. Why is being open such a big deal here?
It's huge. The core idea behind open standards is avoiding vendor lock-in. Simple as that. When your data is in an open format, you have more freedom. Freedom to choose the best tools for different jobs. Freedom to share data more easily across teams or even companies. If you use a proprietary format, you're kind of stuck in that one vendor's world. Open formats like Apache Iceberg define a standard way to organize and manage huge data sets for analytics. This means different engines, Spark, Flink, Trino, Snowflake, Databricks, can all read and write the same data without needing special, clunky connectors or copying data all over the place.
Okay, so it unlocks the data, makes it easier to work with across different systems.
Exactly. It fosters a more open, flexible data ecosystem. And Snowflake has really leaned into this with Iceberg. Needleman's article talks about 2 main ways they do it: Snowflake managed Iceberg tables and externally managed one.
Right. Let's break that down. What's a Snowflake managed Iceberg table?
Okay, so with Snowflake managed, the actual data files, the Parquet files, usually live in your cloud storage bucket. S3, Azure Blob, Google Cloud Storage, your choice.
Your storage. Okay. But the critical piece, the metadata layer, the catalog that tracks the files, the schema, the partitions, all that structure that's managed by Snowflake itself. So you get the benefits of the open Iceberg format for the data, but you also get Snowflake's performance, security, governance, data sharing applied to that data. And importantly, that Snowflake-managed metadata is still accessible to other tools. They provide an open-source SDK and something called the Snowflake Open Catalog, so other engines can understand it.
Ah, I see. So Snowflake handles the tricky bits, the organization, but the data is fundamentally open and usable elsewhere. Makes sense. What about the other kind, externally managed?
That's for when you already have Iceberg data that maybe another tool, like Spark, created and is managing. In that case, Snowflake can connect to and query that existing Iceberg data directly. Needleman notes this is way faster than old-school external tables. Here, the metadata catalog lives outside Snowflake.
Sure.
Maybe it's AWS Glue, maybe it's a self-managed catalog, and Snowflake just reads from it.
Got it. So Snowflake can either be the Iceberg manager or play nicely with Iceberg tables managed by others. The article got a bit technical talking about setting up the Snowflake managed ones. External volumes, catalog Snowflake. What's the main takeaway for someone not actually doing the setup?
The key takeaway is they've tried to make using Iceberg within Snowflake pretty straightforward. The external volume is basically just telling Snowflake, hey, here's the cloud storage location where my Iceberg data lives or will live.
Mm-hmm.
And adding catalog Snowflake when you create the table just tells Snowflake, okay, you're in charge of the Iceberg metadata for this one.
Hmm.
Needleman mentions external stages aren't strictly needed but can be handy for seeing the files. But the goal is clear. Make it easy to adopt open formats without giving up the Snowflake experience.
Okay, and then there was the Snowflake Open Catalog. Needleman said it helps connect systems like Databricks. What is that exactly?
Yeah, the Open Catalog, which is built on an open source project called Polaris, by the way, is essentially a managed service from Snowflake that acts as a central directory for your Iceberg tables. It makes it much simpler for other engines like Databricks to find and securely access those Snowflake-managed Iceberg tables. Because it's managed by Snowflake, it takes care of the underlying infrastructure for the catalog itself, and it handles things like security credentials and RBAC. So you manage permissions in one place.
Ah, so instead of juggling lots of separate connections and security setups, you get a central hub for managing access to your Iceberg data.
Exactly that. Needleman walks through connecting Databricks to this open catalog and then just querying the Snowflake-managed Iceberg tables like they were native. He even showed it working across clouds data in AWS S3, Snowflake in maybe a different AWS region, and Databricks running over in Azure.
Wow.
It really shows the power of open standards for genuine cross-cloud work and data sharing.
That is pretty powerful. Sounds like Snowflake is serious about playing in a wider, more open data world, not just keeping things in their own garden. Okay, let's pivot a bit. We've talked structured data, tables, but what about, the messy stuff? Documents, PDFs, that Snowflake Lakehouse article seemed to touch on this.
That's right. That piece explored Snowflake's evolution, moving beyond just being a warehouse for structured data towards being a true data lakehouse, which means a single platform that handles structured data, semi-structured like JSON or Avro, which they've been good at for a while, and now increasingly unstructured data too, all in one place. Being able to work directly with things like PDFs inside Snowflake is a pretty big step.
So how does that work? If I have, say, 1 million PDF invoices, how do I get insights from them in Snowflake, which is usually about rows and columns?
Well, first step is getting them in. You typically load them into an internal stage that's secure storage area within Snowflake.
Okay, upload the files, then what?
Then you need to extract the useful information. Needleman covered a few ways to tackle this for PDFs.
Like what?
A major one is using UDF's user-defined functions. Snowflake lets you write code in Java or Python right inside the platform. So you could write a Java UDF using a library like Apache PDF Box, or a Python UDF using something like PyPDF2.
Ah, using standard library.
Exactly, to basically read the PDF file and pull out all the text content.
Okay, so you extract the raw text. Then you can query that text.
Yep. Once you have the text, you can hit it with standard SQL functions. Search for keywords, pull out dates, invoice numbers, amounts, whatever's relevant. You can even apply fancier text analytics. And Needleman also mentions Snowflake Cortex. It has built-in functions, including one called Parse Document. This one's cool because it can do OCR, optical character recognition, so it can even pull text out of scanned images within the PDFs. Make scanned documents searchable too.
OCR built in, that's really handy. What about performance if you're processing tons of these big, awkward files?
That's where Snowflake's separate storage and compute architecture is key. If you need more power to process a huge batch of PDFs, you just temporarily scale up your virtual warehouse, the compute engine, make it bigger. Needleman mentioned a demo where they chewed through 10,000 PDFs, like a gigabyte of data, in about 40 seconds just by bumping up the warehouse size.
Wow.
That ability to scale compute up and down independently is perfect for these kinds of bursty, heavy processing tasks on diverse data.
So the same platform handles your regular tables and your messy documents, and you just dial up the power when needed. That definitely simplifies things. Okay, what about data that's not sitting still? Data that's flowing in constantly, streaming data. That streaming on Snowflake article sounded interesting.
Yes, that one focused on how Snowflake is tackling near real-time data ingestion and analysis. Needleman pointed out that getting insights from data with very low latency has traditionally been tough, often needing separate, complex streaming systems. Snowflake's goal is to make it easier by offering different ways to connect and process streams.
What are the main ways they handle streaming?
He described 3 main patterns. First is Snowpipe. That's their workhorse for loading data in small batches, usually from cloud storage. Files land in S3 or wherever, Snowpipe notices, and loads them into Snowflake tables. It's not true, continuous real-time, but it's often low latency enough, micro-batching, basically.
Okay, Snowpy for files. What else?
Second is the Kafka connector. Kafka is, super popular for event streaming. This connector links Kafka topics directly to Snowflake. It pulls data from Kafka, puts it into an internal Snowflake stage, and then uses Snowpipe under the hood to load it into tables.
So Kafka handles the stream, Snowflake uses the connector, and Snowpipe to ingest it. Got it. What was the third way?
The third one, which was newer when the article came out, is Kafka with Snowpipe streaming. This is a much more direct, lower latency connection. It uses a new thing called a channel object in Snowflake. Instead of staging files first, it streams data directly from Kafka into Snowflake tables using a specific Snowpipe streaming API, much faster ingestion.
Ah, direct streaming. That sounds like the closest to actual real-time. The article used an example of a retailer processing point-of-sale POS transactions. How does Snowflake help there compared to older systems?
Yeah, older systems often choke on the sheer speed and volume of data from, say, thousands of cash registers. They might struggle to store lots of history cheaply or analyze transactions quickly enough. Snowflake's elastic nature handles the volume easily. You can store petabytes affordably and scale the compute power up for peak hours, then down again. And the different streaming options let the retailer pick the right latency. Snowpipe streaming especially could let them analyze sales almost as they happen for immediate stock checks, fraud detection, that kind of thing.
And didn't they compare the performance of these streaming methods?
They did. Their tests showed, kind of as you'd expect, that regular Snowpipe is solid for file batches. The Kafka connector was generally faster for streams because it batches messages efficiently. But Snowpipe streaming was the winner for lowest latency, getting data queryable in Snowflake in just seconds because it skips that intermediate staging step.
And the real magic seems to be combining that fresh streaming data with all your historical data, right? In the same place.
Exactly. Needleman gave that example, joining live POS data streams with years of past sales data. Lets you spot trends instantly, see how promotions are doing in real time, feed prediction models, all unified. No moving data between a streaming system and an analytical warehouse.
That unified view is definitely powerful, timely, and deep insights. Okay, so we've seen Snowflake handle structured, unstructured, and streaming data. Now let's tie it all back to AI and machine learning. That first security article had that little AI anyone aside. And the Lakehouse piece mentioned a predictive sales model. How does Snowflake actually help with AML?
Well, it provides a really strong foundation for AI and ML work. A big piece is Snowpark, their support for running Python code directly inside Snowflake. This is huge for data scientists. They can write their Python code, use familiar libraries like pandas or scikit-learn, but execute it right where the data lives.
Ah, bringing the code to the data instead of moving massive data sets out.
Precisely. It's much more efficient, especially for training models on large amounts of data. Reduces data movement, simplifies security.
So data scientists get to use their favorite Python tools within Snowflake's secure environment.
Exactly. Plus, Snowflake is adding more built-in ML functions, too. Needleman mentioned time series forecasting as one example you can run with just SQL.
And I guess having all that different data, structured, unstructured text, streaming feeds readily available in one platform must be a huge plus for building sophisticated AI models, right? They thrive on diverse data.
Absolutely critical. Modern AI often needs that mix. Training a model on sales figures, structured, refining it with customer reviews, unstructured text, maybe even using real-time sensor data, streaming for predictions. Snowflake acting as that single source of truth, that unified platform for accessing, prepping, and managing all that diverse data, really removes friction.
Yeah.
It helps break down those silos between data engineering, analytics, and data science, letting organizations move faster on their AM goals.
Okay, wow. We have covered a lot of ground here. We started with the idea that Snowflake is more than just speed, highlighting its really robust security, governance, and resilience features, that foundation of trust. Then we dove into the open standards piece, how Iceberg support makes it play well with others like Databricks, avoiding lock-in. We looked at how it's tackling unstructured data, like processing PDFs, and how it handles real-time streaming for those immediate insights. And finally, how all of that comes together to support AI and ML by providing that unified, scalable platform.
That's a great summary. Yeah, it really paints a picture of Snowflake as this modern cloud-native hub designed to simplify the whole data lifecycle. It handles a lot of the underlying complexity so teams can spend less time managing infrastructure and more time actually finding insights and building things.
So for everyone listening, maybe wrestling with their own data headaches, what's the final thought to chew on?
Hard to say. Think about where your data silos are. What's holding you back from getting the insights you need? when you need them. Consider the value locked up in data you're not using effectively today, maybe those documents, those real-time feeds. And then picture what you could do with a platform that brings it all together, securely, scalably, openly, supporting everything from basic reports to your most ambitious AI projects. How could that kind of unification accelerate your journey to better decisions and more innovation? It's worth exploring what that could unlock.